Welcome back to Area Diesel Service. Today is an exciting day. Today we are going to bring you some new collaborative content with fellow YouTube creator MortskeRepair. If you're not familiar with MortskeRepair, please go check him out. Mortske does some of the best will it run, resurrection, and rustorations on YouTube. Mortske inherited a 1978 C10 Chevy pickup. This rolling chassis that he's got is factory equipped with the legendary 5.7 liter V8 diesel. We'll talk a little bit about why it's so legendary in a minute. So Mortske started in on this will it run project, and he got into a little bit of a snag with the injection. He found that he had the famous flex ring failure inside the pump. He pulled the pump off the engine, started in, disassembled it, and that's where he decided that he was maybe in over his head, and he reached out to Area Diesel Service for some help. And that's where we're at today. So this is Mortske's pump, and we're going to open it up and take a look and see what's going on. This pump is kind of legendary because it's one of the pumps that kind of started it all. So the story, as I understand it, keep in mind I wasn't even alive when this was going on, but back in the day, Mortske stickers, thank you sir. Back in the day, 1973 Area Diesel started. This was kind of the height of the oil embargo, so those troubling times a few years later sparked Congress to pass the Conservation Act of 1975. That led to what we know today as CAFE standards, corporate average fuel economy requirements by the federal government. And in 1978 the first set of requirements came out. This unit being from 1978 was one of the first victims. So the government said, manufacturers, you need to increase your fuel efficiency, and GM's solution to that was to start to go to the diesel engine. This is one of the first examples. So again, as I understand it, GM was somewhat rushed to satisfy these new requirements, and they started with kind of the foundation of the Oldsmobile gasoline powered 350, and they modified that engine to burn diesel fuel. So turned out to be not a very good move. The gas version was probably 8-to-1 compression. They bumped it to 22.5, and it was problematic. Noisy, cold-natured, smoky, and not reliable. And the public was not a very big fan of it. They continued it for a few years, made some improvements throughout its history. It just didn't go over very well. Alright, so what is this thing? This is a Stanadyne pump. In this era they were known as Roosa Master. Today that company name has changed and we refer to them as Stanadyne. This is a DB2 style pump, DB2-825-3633. So DB2 being the general model of the pump. The first 2 in the designation indicates a 2-element pumping system. DB2 8 cylinders, V8. DB2 825, the 25 indicating a 250 thousandths diameter plunger. Dash 3633 is the specific bill of materials and calibration specifications for this assembly. So this particular pump uses what we call a min-max style governor. The governor is operating at minimum, so idle speed, and maximum, so full load. Everything in between is handled by the foot feed. So this engine with this pump in its factory setting had a horsepower rating of 120, a real gem. Full load fuel delivery occurs at 4,000 RPM, and in its factory configuration, this pump is calibrated to deliver 43 cubic millimeters of fuel at full load. So that ain't very much. To put that in perspective, a hot street pump, P-pump 5.9 Cummins type configuration, we may calibrate to say 700 milliliters of fuel, or a pulling pump, same frame, you might be seeing 1,500 cubic millimeters of fuel. So not much coming out of this DB2. So the real limitation in this pump is the plunger size. Right here, 1/4 inch plunger, just isn't taking a very big bite. And we can make some adjustments in delivery, allowing the plunger to extend further and take a larger bite of fuel, increasing fuel delivery. But we've got to be a little cautious. Again, this power plant is not going to take a whole bunch of added power. Factory roller to roller dimension is 1.977 inches. We can shoot for 1.999 inches, just under 2 inches of roller to roller dimension, and we might go from 43 cubic millimeters of fuel to say maybe 60. There is an opportunity to increase the diameter of the plunger. That would require a new head and rotor assembly. There is a common 310 thousandths plunger that we may look at putting in this pump. Alright, so Mortske's been in here obviously. He indicates a flex ring failure. We're going to take a look and see if we find the same situation. Flex ring, this is the governor weight retainer cage. This is the rotor out of the head, and the flex ring goes on this assembly here. And we can see it's coming apart. So that is one of the primary modes of failure on these rotary style pumps. This flex ring starts to deteriorate, turns into coffee grounds, and this debris is introduced into the pump, and it starts to plug things up and it won't pump. The updated flex ring is kind of a white or transparent flex ring. This one is not susceptible to breaking down. There's also an update that you can eliminate the flex ring entirely, go to a solid one-piece style weight retainer cage. So what is happening when that occurs is the return from the pump. So fuel is fed to the pump, comes in the back, there's a transfer pump that builds supply pressure to the pump. That's what feeds the pumping element in the head and rotor. When the return plugs up, the pressure in the housing becomes higher than the transfer pump pressure that's feeding the pumping element. When there's no differential in pressure, the plunger cannot come out to take another bite of fuel and charge the cylinder or feed the injector. So a lot of times you can take the return line off, knock the debris out of the return connector, and your machine will fire up again and start to run until more of the coffee grounds get plugged up, housing pressure climbs, the differential in pressure at the plunger ceases to exist, the pump will no longer pump fuel. So once it starts, you can sometimes nurse it along, but it's going to be game over soon. It's going to plug up and you're going to be out of business. We don't generally get pumps in for repair in this fashion, but it gives us an opportunity here at the counter to kind of look at some of these components and see if we can tell what was going on. So we know the flex ring is out, likely contaminated the pump. The other common thing that we see, especially in this scenario, when these things sit, is this pumping element, the plunger itself, will become stuck in the head, right? They sit with old fuel, and that is definitely the case here. So if Mortske hadn't realized this, cleaned everything up, took the debris out, this thing still wouldn't have ran. The plungers are stuck. They'll likely come out and clean up okay, but we won't know until we get them out of there. Head and rotor, critical component. These fit and finish between the head and rotor are critical. This is what is pumping the high pressure fuel to the injector and then The rotor is obviously what distributes it to the specific cylinder. Critical component, the plungers rotate around inside of this cam. So this is the cam ring. As the plungers go around in this fashion, they encounter the lobes, they move in and out. That's what pumps the fuel. Cam ring looks like it's probably going to be alright. We'll let Corey make that determination. Governor weight cage. So this is the fuel inlet. So head and rotor goes in here, fuel inlet here. This is where the transfer pump, so the first stage of fuel pressure comes from. There are these blades go inside of these grooves. They pass through this eccentric ring, and like any vane pump, that's where your first stage fuel pressure comes from. Supply pump shows where. We'll let Corey again determine whether or not we go with that. Everything else appears to be there. It's dirty and cruddy, but should clean up and go back together just fine. Alright, so this kind of lends to one of our most popular questions, and that is, should I attempt to repair my pump myself? And the answer is, we don't really know. We don't know your level of capabilities. We regularly experience this, so we're happy to have the work, but we get a lot of this. Folks take them apart and say, oh my God, I'm in over my head. Let me send it out to someone that can take care of it and get it back to me. If you're capable and willing, we're certainly here and available to help you with some parts or maybe some expertise along the way. But there's a lot of parts in here, and it takes quite a bit of knowledge to get them all back together. And even if you can pull it off, and we certainly hope you can if you try it, you likely won't have the calibration equipment to set back to the proper fuel deliveries, governor speeds, and things of that nature. So yeah, a lot of folks are certainly capable of disassembling and reassembling just like they found it, but then how do you calibrate it? Also takes away our opportunity to gain knowledge through the disassembly process, right? Our technicians are looking for the smoking gun as they're coming apart. They know the symptom, they know the application, they know the scenario, and during the disassembly process, they're on the hunt to find the problem. Maybe it's a setting, maybe it's a component orientation, something, but when we get them in this condition, we don't get that opportunity. So we basically have to clean everything up, put it back together, and if the problem is not obvious, we pick it up on the test stand, and then we get an idea of what the failure might be. Generally, not a big deal. They can pick it up with their eye, they know the components that fail, but many times put them back together, clean them up, put them together, put them on the stand, still an issue, come back apart. It kind of lends to one of the common thoughts, hey, I disassembled it, I should have saved you some labor time, my bill should be less. But in reality, it just doesn't work out that way. We lose the opportunity to make note of the lever orientation. Some of the fittings might go in different places. If that's all been taken apart, it takes more time to look up and figure out what is that orientation, where do these components go. And again, if we miss the failure during the cleanup and assembly, we may have to come back down and go back into repair after we pick it up on the test stand. Just some things to think about there. Anyway, that's probably way too much rambling. We're going to write this up, generate a work order in the system. We're going to give this pile to the experts in the fuel shop, let them work their magic, and then we'll meet you back at the parts counter and review what occurred.
Hey everybody, it's Corey again. I got this pump here for MortskeRepair. As you saw, Kurt kind of showed you how it kind of came to me in basically this state. However, I've cleaned it up quite a bit already. You guys have already seen me clean up a couple pumps before on some of the other videos I've done, so we didn't feel it was too important on this one. But regardless, I got that flex ring cleaned out of there, so that's fine. All the parts, you know, I went through, kind of decided, okay, what parts are bad, what parts are good. I was able to save a few parts, but there's still some parts that are kind of mandatory to replace. So my first kind of go through of the pump was there were several parts that were stuck because of the fuel contamination, like especially his pumping plungers. They were stuck, so there was no way I was going to pump any fuel. And it looked like his delivery valve was stuck too, because I had to kind of pull it out. So both those things not good for trying to start your engine. And also, I've noticed that this leaf spring is backed out quite a ways. So, I'm assuming that he did that, but I don't really know, mainly because this is how I got it. So, that's kind of some of the trouble of getting a pump in that's already torn apart, because I really have no idea what it honestly looked like whenever it was together. You know, I have a rough idea of how the general shape of it was, you know, just by looking at the parts that were on here, but there, you know, I could have maybe gained a little bit more from actually seeing it and tearing it down myself. Also, this particular pump, so this is off of 5.7. This particular design I've actually never done before. So, out of the 5 years I've been doing these, this particular design I haven't done, haven't seen. So there are a couple parts that are unique, I guess you could say, but for the most part, these pumps are all fairly generic, so it's nothing really to be worried about. It's just another pump on the bench. But these are two pumps. These are also automotive pumps. So this one here is off of a Ford because it has the round flange, and the lever's on this would be the right side, viewing from the end cone side. And this would probably be off of a 6.9 if I was to guess, just from my general knowledge. So the biggest thing on these is that both of these pumps here, this is what's called a face cam, which then goes through this rocker lever, which then goes to your advance. So as you move your throttle back and forth, it goes up and down this face cam. Well, with that, it basically just changes the pressure on your advance piston, which changes how your advance moves. So, more fuel you got, less advance you have. The less fuel you're making, the more advance you have. You know, it just helps you run your engine a little bit smoother. But this particular pump doesn't have that at all. It's more of a mechanical style advance, like other DB2s or other DBGs, to where these are like an early light load advance, in a sense, to where your advance is dependent on your fuel delivery. Like I said, this one's probably off a 6.9 Ford, where this one is, if I was to guess, probably a 6.2 GM. So as you can see, this is a triangle flange, which is indicative to GMs. However, you know, this pump that we have here is also off a GM, but this is a very early GM, so it has a round flange like some of the other DBG pumps, and it has a steel pilot bushing. So, and it does not have a face cam. So, slightly different, unique to this style or this era of DB2s, but like I said, for the most part, parts-wise, they're mostly the same. This is a little bit different design, but still same concept. It's a min-max governor, which is all your automotive pumps are, instead of like an all-speed. So just some few differences. So as we're at right now, I've got everything cleaned up. I'm going to now start putting it back together and making sure everything is free and actually correct for this pump. So I'm just going to move these out of my way. Okay, so got everything cleaned up. I got my parts buffed on a couple of these. I think it's these two right here. Yeah, so these two here he has loose, so I'm going to have to retorque those in. I would not really ever suggest trying to take these out, because these are torqued to a specific spec, and if you were to take all of them out, then technically speaking, it could change the shape of your sleeve inside of your head here, and it could make your head not work. So, would not suggest it. A couple of them like this isn't a big deal, but you don't really want to take all of them out, especially all of them at the same time. Also, several of these are kind of nicked up and banged up, so I'm going to have to run a tap across them, but it's no big deal. It's nothing inherently unusual, depending on, you know, the core I got or whatever. So, got my housing here all blasted up, so it's nice and clean. But one thing that I'm going to have to do to this particular one is it has brass bushings, brass throttle shaft bushings, so I'm going to replace those with steel bushings, which is basically what I do with every single pump. If it comes in with brass bushings, I replace them just because brass wears out very easily and a steel one obviously will not. So just got it mounted on here to make it easier for me. These are just some tools that I got here to help me replace these bushings. Put on my safety glasses for this. So basically I just do this one at a time. Tap the old one out. This inner space here is just so it doesn't collapse the housing. Throw that away. Got my brand new steel bushing. Throw a little bit of Loctite on the outside. Then put it on this tool. Okay. There we go. Wipe off the excess. Loctite just helps it seal so no fuel gets around the outside of it. Okay, so we got our brand new bushings in here. So that's fine now. So I can kind of go about this. I'm going to actually have to build it a little bit different than the other style DB2s just because this one isn't kind of made the same. So this is going to be built more like a ag-based DB2 rather than a automotive based. So I'm just going to throw this. This is your governor arm and linkage with your cross shaft. As you've seen on my other videos, see how this is important on the direction that this goes in. So normally on other automotive style DB2s, there is no cross shaft, there's a pin in the housing, so it actually pivots on the pin rather than on a shaft. So that's how this is a little bit different. So normally, like on the other ones, I would actually slip the head in first and then put the governor arm in later. So just slightly different concept. I don't know if in the later years they found that it was easier or better to go with the pin style, whether they found that it was just a necessary improvement. Got my new O-rings on there. A little grease on there. Try and make these as even as possible. Okay, so that's good. On this particular one, we're going to hopefully give him a little bit more horsepower, which means I'm going to have to turn up the roll-to-roller setting. So I'm going to start by turning this leaf spring in all the way just to see kind of where it will go to, because I very well might have to switch it to a bigger numbered leaf spring. And see if that will give me enough to where I think it'll be where it needs to be, because where he's wanting it set, I have a rough idea where I kind of want to set it, but I'm not 100%, so I may have to adjust it on the stand. But first, I have my brand new delivery valve here, which his old one was stuck, and of course it was worn out, so we got to replace it. Spray some 104 on there. This delivery valve spring looks okay. Another brand new stop. screw. Okay, that slid down easy enough, so I shouldn't have a problem whenever I go to the stand. This gets torqued in, because if it's not torqued high enough, it'll leak. And if it's torqued in too much, then it'll seize. So that's torqued in. Put a little bit of calibration fluid on here, make it smooth. That was still maybe sticking a little bit, but it's freed up decent. Okay, so I'm going to stick this head into the housing here so I can torque these fittings on here. Just makes it easier for me if I have it bolted in here. And then I'll tap all these fittings as well. Make sure the threads are clean. Okay, that one's good. Need some grease on those. Okay. Since he had those two loose, I'll just check all of them while I'm here. Okay, yep, all of those are fine. It's just those two that were loose. Tap. Okay, now that I got all that tapped, I can take this back out. I'll blow all those fittings out. Just get rid of any metal shavings. Now time to make sure that these plungers are free. Usually once you kind of push them out and get it cleaned up, normally they're pretty free. It's still kind of stiff. Okay, that's good. As you can see though, these are still wanting to stick a little bit. Just has to be completely free, otherwise it will not work. There we go. those are free enough now. One thing that was also weird about this pump here is that it uses hollow rollers, which most time those are solid. I don't really know why they designed it with hollow rollers. Don't really think it makes any difference, but it's just something different about it. Make sure these are free. Okay. Let's do this in. Okay, so basically, like I said, I screwed his original leaf spring all the way in just to see kind of what it'll make for my dimension. And I know what the stock dimension is, so I'm just trying to see how much higher it can go and whether or not I think it'll be enough to get me the fuel delivery that he wants. Okay. It's free. Also, I'm going to check, make sure this doesn't leak. Which it does not, so that's good. Okay, so this, with this leaf spring here, it only gets me, it'd be 8 thousandths over stock spec, which, according to where I think it should be for the fuel that he wants, I don't think that's going to be enough. So I'm going to have to switch it out for a bigger leaf spring, which isn't really all that big of a deal. But that would be where, that's one of those things where if you were to send in your pump in and let's say you're like, okay, go through it, rebuild it. Okay, we rebuild it, we set it to stock spec and make stock fuel fine, maybe a couple over. Okay, no big deal. Well, then you're like, oh, well, actually, can you guys set it, 10 or 15% over? It's like, okay, yeah, we can do that. But in this instance, let's say on the stand, I might turn it up, might make your 10 or 15% over. Just fine. Okay, no big deal. Run it all through, send it back to you. Where if I tried to turn it up and that leaf spring was too tight and I couldn't get that, well, now I got to take the whole pump back apart, reset it, switch out the leaf spring, rerun it, and then send it to you. So that's something where us knowing what you want is very beneficial time-wise, because it could cost you extra just for that slight change. Because if I have to take it back apart and then rerun it, you're looking probably at least an hour to 2. So if you could, if we know this information to start, then I can, I've done this enough to where I kind of know where it needs to be set at. So then I can judge a little bit better on, okay, do I think this is going to be enough or do I not? So that's definitely something that you may want to keep in mind at any point you might want to send something in, because the more information you can give us, the better. Whether it be what was going on with the pump, whether you want it to be stock or 10% over, or whether it was just leaking even. Because if you're saying that, oh, it was just leaking, and then I get on the stand and it doesn't make cranking, it's like, well, okay, then we got to go through other processes to determine if we think it's good enough. Okay, so now we are definitely making enough. And I still got a little bit of room to go. Okay, so this is just a kind of a wild guess, just based off of my own experience. I'm gonna try and get it close, but we'll see once we get it on the stand. Right now I think it's turned up too much. I actually think I'm going to leave it right there. Because like I said, I'm just honestly just trying to get it halfway close so that way I don't have to turn it up a lot on the stand, but obviously my guess is as good as any on, because also you might turn one pump up a certain amount, it might make your fuel, and you might turn up another one the same amount, it might not even be close. It really just depends on the wear of the head and other circumstances. Okay, so we got our delivery valve checked, it's not leaking, got all these torqued and tapped, got this set. So now basically I am ready to put the head in the pump. These are maybe kind of sticking a little bit, so just want to double check these. That's fine. Okay. Got my head O-ring here. Put that on first. Then put your cam. Got to put it on the correct rotation. This one is counterclockwise, which is indicative to a GM. GMs are always counterclockwise, where Fords are always clockwise rotation. So that's good. The cam looked good. So now, before I put this on, so you got your weight cage and your retainer. Then I will marry those together and put my leaf spring on here. But before I do that, I'm going to check the timing mark that's on here, which is right here. So I got my degree set. This back up. Okay. Let me make sure. Let me find my time. There it is. Okay, so I'm going in the arrow, the direction of the arrow. We are spot on. Okay, so that's good. Of course, your timing marks are dependent on the application of the pump, so mostly all pumps use a different timing mark, you know, within their own generation, I guess you could say, or application. Okay, make sure that hole's open. Got a brand new flex ring. So this is what they start out as, then they turn brown or black and they get brittle and they break apart, and that's what happened with this pump here. Which, of course, that's why, you know, that very well might have been one of the problems of why it was parked to begin with, because the leaf spring broke, so it probably wasn't regulating RPMs correctly. And then once it sat, then it got the fuel contamination. That's when everything started to stick. So, go hole by hole and stick that on the pins. I'm sure some people have tried this and it's taken them, you know, a good while to get all these pins on here, but luckily I've done enough to where it's really no big deal. Usually it's always a challenge for the new guys to get these flex rings on. Okay. Go around, double check these. I did get all the old flex ring parts out from underneath here, so don't have to worry about those being in there and maybe causing a bit of trouble. So that's good. Cam's on the right way. Line up our lines. Put our clip on here. Okay. So now that's connected to the rotor. Flip it over. Got our in-cone O-ring. Stick that in. Now, got our rotor retainers. line them up with the hole. Got our plate here. So that makes sure that's all held together. This is the original supply pump liner. I thought that was still in good enough shape to where it could be reused. Got that on there. These are brand new blades and springs. This is something that I basically always replace. Okay, put a little bit of calibration fluid in there. Now, this is your transfer pressure regulator. So got our piston, which goes in first, and our spring, and our screw. So basically I'm just going to turn this into where it's flush, and then I'm going to have to set that on the stand. That's close enough. Okay, this particular one here, being an older design, it uses this one, which uses this rubber, like umbrella seal type deal, and then this is a metal filter with a chamfered part here. Normally it's like a plastic filter that snaps on there, so it's just an older design. Same concept though. So that's all on there. Got my end cone here. I cleaned it up. I took his line out of here and I buffed it up so it's nice and clean. Put some grease on here because you don't want to cut that O-ring or have it bunch up or anything like that. So just put a light amount of grease where the O-ring goes. Basically for now I'm just hand tightening it. I'll torque it in once I put it in the pump. Okay. This one here also uses a cam screw for the advance, where the other ones, they actually use a servo piston, which then uses a cam pin that goes through the piston and into the cam. So again, another design change between this style and the other styles. Still is the same concept, does the same purpose, it's just design wise it's different. Put the weights in. Have our thrust washer and our thrust sleeve. Okay, so that's all good. None of the weights are out of skew or anything like that. So basically that is now ready to go into here. We got our housing set up with this. Made sure all the holes were open. Got our new bushings in, so it's ready. So I'm just going to put a little bit of grease in here to help slide the head in. Tilt this down. Make sure that's all lined up. Okay, so that's in there. It didn't go too far. If you go too far, then you have to back it out. 90% of the time it rips the O-ring. So it's definitely something that you want to watch for, because if that O-ring gets ripped, then you're going to be leaking on the stand or on the engine, and then you got to take it back apart, and it's never a good thing. So this is original metering valve. It's worn out, can't be used. So got to switch out the arm to a new metering valve, which is very common. It's a wear item that I almost always have to replace. Every once in a while I do reuse them if they're not worn too bad. Okay, so now that's on there. I'm going to bend this up a little bit. sometimes bending that spring up helps with your low idle, so sometimes you can have what's called like a low idle underrun. It's where whenever you go from, you know, running down to like a stop sign, okay, let the foot off the gas, it'll go down, it'll go, and then it'll come back. Well, sometimes that helps with that, just by bending that spring up a little bit. Basically all that does is just puts the metering valve in a different height position inside the head. Okay, so that's all good. Okay, we got those in, we got that in, got our metering valve in, which it's free. So now we can stand this up, put our bottom head bolt in. Got to make sure this check ball is free, which it is. Got my little O-ring sleeve here. Torque these in. Of course, this one gets torqued in first. Okay. This for the end cone. Now I can torque this in since it's right here. It's also one of those things, if you don't torque that in, it will not work on the stand. Okay, I'm pretty happy with that. So this is where normally I would stick my advanced piston in, make sure it was free, and then slide the cam pin in, where this one I'm actually going to have to put my cam screw in and then torque it down. I found a major problem. Okay, so I found that the threads in here are basically gone. So basically this plug right here screws into here. Well, obviously if the threads are gone, then the plug won't fit. So now with that being said, I'm going to have to take this back apart and find me a different housing because there's no real way for me to fix those threads. Okay, so I found my housing here. Luckily I had one in our spare hoard of parts. It looks pretty good. Seems to be the same housing. However, it has the brass bushings, so I'll take the steel bushings out of this one and press them into that one. Which, that's no big deal. This one cleaned up pretty nice. Shouldn't have any problems with it. I'm going to have to start taking all this back apart. Which, that's one of those things, you know, did that happen whenever he took it apart? Was it already kind of like that before? And then whenever he took it out, it kind of progressed with that problem? You know, who really knows? Okay, through the power of magic, we are back to where we were. So, I got everything switched over to this housing. Seems to be good. Checked all the threads multiple times. So now I'm back to where I am screwing in the cam screw. Hopefully that's the only problem I run into. Okay, so that's all free and good. This particular pump here has a different style power piston cap and power piston I've really never seen before, and I find it very interesting because it's like half the size as a normal one, so I'm kind of curious on why they felt the need to make it this shape, but I guess we'll never really know. Still does the same thing. You know, still just has fuel come in here and pushes out your power piston and moves your cam screws. So that part of it's still the same, but they apparently just wanted it to look different. There, okay. This old O-ring off here. I've also never seen a screw with that type of end on it, so that's kind of interesting. Our adjusting plate in there, got our 2 springs, piston, grease on there. Okay, now I can actually put this plug into a good housing. It was not going to work in that other housing. Okay. Now we can basically stand this back up flat. Nice and free, so that's good. Put our O-rings on this. Okay, so this is where this end has to be on this side because his transmission deal here goes on the end of this with a pin that goes through here. So you have to make sure you stick your lever in from the right side. Okay, and that is nice and free. And one way you can tell is that this is your high idle screw and this is your low idle screw, so high idle has to be on this side and low idle has to be on that side. If it was on the other way, it'd be wrong. This is also where this one is different because it actually uses this clip here to hold that shaft in, which even if that clip is there, it's going to have a little bit of end play, so I'm going to put a couple shims on there. Okay. So I got a couple shims on there. Stick this on here. Perfect. It's just a little bit of end play, but nothing crazy. Got our min-max spring assembly, so this just goes on here. Okay. And we have our guide stud here with our washer. Sometimes with these there's a spring inside that min-max assembly, and that kind of helps your torque back up in a sense. It's nice and free, so that's good. Our plug and our washer, it goes right here. Sometimes a torque screw goes there, but this one doesn't need it. Basically now I got left is just a solenoid, which will go into your top cover. thing we'll do is we will check this real quick. Okay, so that is perceived to be good. Of course, I've had them test good in here and still fail on the stand, especially once they get hot. Got our new little grommets here. I cleaned up this top cover earlier, so don't have to worry about that. Okay, we just got all these washers and block washers. Also on the other DB2 Automotives, the top cover is different because it has another solenoid here which runs kind of like a cold start in a sense, to where once if you hook power up to it, then it lets your advance move, so where this one doesn't have that. Which is, I guess, a little bit easier on me, building wise and running wise. Normally they work, but it's still one more thing you gotta check. Okay, so I got this all together. Get your new O-ring. I'm going to slide this on here. When the lock washer goes underneath. Got our brand new return connector. Of course, I replaced this because with that flex string being broke, of course all of those little bitty pieces settled into here, so instead of trying to clean it out, I just replace it. I just find it's a little more safe for me to do that instead of taking a chance. Okay, so basically now all you gotta do is just stamp it, then we're ready for the test stand. Okay, so I got the pump here on the stand, got it all hooked up. Sorry to break it to you, but I already got it warmed up, already fired it up, so it does work. But I haven't said anything yet, so basically now I've just got it to a point where it's warm, so it'll be an accurate test, because that's really the main purpose of this. Because I can throw it on here, and I can make sure it works, but if it's not accurate, then it's not really doing us any good. So, got it all hooked up. So now I'm going to fire it up for you guys. I'm going to have to reset this advance gauge, but other than that, I got some minor tweaks I got to do, so you guys will be able to see that. So I'm just going to get her going in here, and I'll try to explain a few things as I go. Just a short explanation. This is my inlet line going in to the pump. This is my return line going to my gauge. I got transfer pressure on the gauge over here, which you can't see. This is my advance gauge. and then these are all my discharge lines going to my injector. Okay. So basically, you know, your fuel comes in, builds pressure, starts the pump, then comes out here, and then this is all my reading up here. So these are all my fuel deliveries, as you'll be able to see that, and then my RPM's up there, but a lot of other stuff isn't really too important. So basically, as you can see, I gotta set this to where it actually zeroes out. As I speed it up and slow it down, you guys will be able to see this gauge go up and down. So a couple things I got to adjust is, for one thing, my transfer pressure is a little low, so I got to turn that in a little bit. And I was shooting for 60 cc's, and we're making 57. So I was close on my guess, but I just need just a scotch more. So I got to stop it, and then I can make my couple adjustments and see if I get it spot on. Get into here in order to change my fuel, which is why I have to kind of basically take it back apart a little bit. Got my Allen wrench here. we were shooting for 60, we got 59.5 right now. So I'm okay with that. So now my transfer pressure's set, my fuel is set. So now I'll go on to my van. Right now it's coming in a little early, so I gotta screw this in and make sure it's coming through. Also, another thing whenever you're running a test like this is repeatability. Because if I run it once and it does one thing, run it again and does another thing, well, obviously something's going on. Because it's got to be accurate. It has to be repeatable. So far my advance is checked out fine. Now I'm going to go down and check my low idle. Got my low idle where I want that to be. I'm going to check shutoff. So basically now I'm going to kill the power to the solenoid, and that should push the metering valve forward, thus shutting off the fuel to the rest of the pump. Okay, so that works fine. Basically all I really need is to get under 4 cc's of delivery, which this one was making way less than that. And even though I shut it off, it still makes quite a bit of noise. That's just the noise of the pump. It doesn't necessarily mean that it's still pumping. So now I'm checking cranking. So this is when you're actually, you know, turning the key and trying to start the engine. Which should be good just because I have the fuel turned up so much. But every once in a while, if the head was bad, it would still fail. But this one is gonna make it. Because I only need 21 cc's minimum. And I'm averaging around like 35, 36. So it definitely helps having it turned up. This is the part of the test that takes the longest. Okay, so yeah, it averaged well over what I needed, so now I just got one more advanced spec and then a couple more fuel specs and then we'll be done. with my last two fuel settings and RPM setting being checked, everything checks out good, everything passed spec. So basically now all I gotta do is just pull it off, cap it up, clean it up, send her back out. Okay, so we got it back in the room here, got it all tested. I got his original drive shaft put back in it with the new seals because that's how I have to airtime it. I have to airtime it with his drive shaft, otherwise, you know, it could be wrong. I got my adapter fitting on the port that it specifies for on the plan. So, this is my air timing tool with also this that'll go in here. So, I'm going to hook air pressure to this. Eventually this will lock up to where this is at the top here. Then once I get it to a repeatable spot, then I'll make my line, and that'll give him something to time off of on the engine. So pretty happy with that. Okay. Okay, so that made my line there. Made a good line. So now at least he can kind of position the pump in line with the mark on the engine, and so he can get that more easily timed. But basically now all I got left is to cap it up and put his fitting on and a couple other things. He has his inlet line here that I'll throw back on there probably. Might just leave it off. But I'll just get this thing buttoned up here and then I'll go wash it, then it'll be out the door. Okay, that's basically it.
We let you follow along for the process here. As you saw, this one was disassembled when we got our hands on it, but we got it back to the fuel shop. We cleaned everything up, inspected all the components. Pump was in pretty good shape. Flex ring failure, the plungers were stuck. We went on to find The housing had a strip thread in it. Corey replaced all of the seals and gaskets, common wear items. We found a donor housing, put this thing back together, ran it off on the stand, and we have a functioning pump again for Mortske's project. So we talked before, factory fuel delivery on this pump was full load at 4,000 RPMs, a real screamer at that engine speed. This thing factory calibrated 43.5 cubic millimeters of fuel. You watched Corey change the leaf spring to increase the effective stroke of the pumping element, and we've got her up to about 60 cc's or cubic millimeters of fuel. Turned it up as per Mortske's request. This thing is going to go back to him and see what it does for horsepower. It's not going to be a perfect proportional increase, right? If 43 is 120 horsepower, we've got it up at 60. You know, maybe pick up 20-30 horsepower. It'll be noticeable given the low starting point, but not just going to be a tire shredder by any means. So good luck with your power level, Mortske. Please keep in mind that this particular project is what we consider repair work. Take it apart, or in this instance it was taken apart for us. Fix what's wrong with it. Let a trained and experienced eye inspect the other components, make the judgment call there, put it back together, calibrate, test, ensure proper functionality, but repair level work. So we also do remanufacturing, which is a much more involved process and requires a significantly higher level of subcomponent part replacement. Just for the record, this is repair work. Fix it, put it back together, get it back on the road. Mortske's crusty old C10 project is not going to command the expense of a fully remanufactured component, right? So this pump, this project with its particulars at today's rate rang up at $887.69. Your results will vary. But know this, we're honest, we're fair, we're capable, and we're devoted to providing quality parts and components and a high quality customer experience. We're going to get this boxed up and sent back to Mortske. This is a full 5.7 liter Resurrection repair kit. 4-pack of pints for Mortske, some sandwiches if you will. Duff Dog, not to be left out. Some kebabs for Duff Dog. Pump for Mortske. Area Diesel mechanics gloves. Keep your hands clean. Insulated mug. Everything you need to put your 5.7 back in service. Should make for a pretty good day in Mortske land. If you haven't been following along from Mortske's channel, please head over there and watch this pump get reinstalled and see if this thing will come back to life. Alright. If you need to get a hold of us, please don't hesitate to do so. You can call us at 800-637-2658. You can log on to our website at areadieselservice.com, where you can chat instantly through the button in the bottom right hand corner of your screen, where you'll have immediate access to a diesel engine expert. You can drop us an email at parts@areadiesel.com, or you can stop by any of our locations in Illinois, Indiana, and Iowa. If you do find yourself in a situation where you could use our parts or services, please reach out to us. If you let us know that you learned of us through this collaborative effort with MortskeRepair, we'll take care of covering the shipping for your parts, and we'll throw in a pair of mechanics gloves or whatever swag we have at that particular time. That's it. Thanks for watching.